Hello, my name is Ethan Melton, and welcome to my presentation of the Torricelli Point. Evangelista Torricelli was a great scientist that lived from October 15th, 1608 to October 25th, 1647. He was most well known for inventing the barometer, although he also made great strides in mathematics. He was the first to calculate the area and center of gravity of the cycloid, and he was also the first to explain how wind actually works. Due to his great strides in the development of wind pressure, the unit of pressure torr is named after him. Here is a picture of what he looks like, in case you were wondering. In the early 17th century, another scientist named Pierre de Fermat proposed a problem. His problem was this: given 3 points in a plane, find a fourth point such that the sum of these 3 distances to the 3 given points is a minimum. So he wanted to find a fourth point so that these 3 points were at a minimum, the distances between the 3 points. So this problem got the attention of Torricelli, who would go on to find a solution. Around 1640, Torricelli proposed his solution to Fermat's problem. A greatly summarized version of his proof goes like so. Let ABC be a triangle with no angle exceeding 120 degrees. So we can see that this creates the triangle ABC. Construct equilateral triangles ABC prime and ACB prime and their circumcircles. So we got A, B, C prime. We got A, C, B prime. And then we got their circumcircles right here. And oh, that was bad. Okay. Then you mark their point of concurrency T. Okay, so just big old blob right there. Due to cyclic quadrilaterals and their properties, T has the desired property Torricelli is looking for. So we can see here that these all lie on the circle, and thus it creates a cyclic quadrilateral. The same is true for these over here. So this makes supplementary angles A and B, C prime and T. Same is true for the other quadrilateral. And apparently this makes it so that T is the minimized distance between A, B, and C. In 1750, another mathematician named Simpson suggested a variant to Torricelli's proof, which is most like the proof I will show today. I'll go over how this proof works in GeoGebra. Hello and welcome to the GeoGebra portion of my video. I will show you how to construct the Torricelli point, as well as show you some interesting little factoids about the point. So first of all, you want to create just any old triangle, something like this. Uh, Although one thing that you want to watch out for is you don't want to have any angles above 120 degrees, so nothing like this. And then you want to construct equilateral triangles that are extended from each sideline. So you want A prime to be opposite from A, B prime to be opposite from B, and C prime to be opposite from C. And then you want to construct lines that connect A to A prime, B to B prime, and C to C prime, like this. And then you notice that all three of these lines meet at a singular point. And this point is T, or the Torricelli point, which is their point of concurrency. So, some interesting facts about the Torricelli point. It is the minimized distance between A prime, B prime, and C prime. And the reason that we know this is because a circle, the circle that this creates right here, these three little angles, they're all 120 degrees, which means it's 1/3 of the circle from C prime to A prime. Same with A prime to B prime and B prime to C prime. Which means that this has effectively minimized the distance between these three points. It gets tricky though when T exits the triangle, because now A prime is way over here and the proof may or may not still work. Another interesting thing is, if you look at the circumcircles of all the equilateral triangles, they all match up at T. And we can look at the cyclic quadrilaterals created by T and the resulting equilateral triangles. So T, B, A prime, C. So, and then the other ones. And if we look at, and because we know with cyclic quadrilaterals, the opposite angles are supplementary. So B prime, we know that would be 60 since it's part of a equilateral triangle. We know that since that's 60, T is 120. Same with A prime, T would be 120. Same with C prime, T would be 120. So that's just another example of how it has been minimized. It minimizes the distance. Also, I've created a tool that has imitated this, where get 3 points and it creates the Torricelli point, which that's pretty cool. I hope you've enjoyed this portion of the video, and I hope it has been helpful. So thank you for watching. Thank you so much for watching my video on the Torricelli point. Here are the references I used for this video. You're welcome to do your own research looking at these sources. Once again, thank you so much, and have a great day.